Hey there everybody, and welcome to the channel. My name is Rich Charpentier, and as always, thanks for stopping by and hanging out for a couple. So today I'm revisiting something from almost a year ago now. Last year I did a short video on WebODM, that's Open Drone Map. Things didn't go so great for me with it, but I've had a lot of people get in touch and say, hey, can you follow up on WebODM? I've been busy with client projects and I haven't done enough testing with WebODM to date. I need to use things that are at the ready for my client jobs. So experimenting with new software in a client job is a bad idea. You got to do those experiments outside of it on your own time. So recently, while I've been working on some other tutorials and other classes and things for Patreon and things for Udemy, I said, you know, I'm going to take a look at WebODM again, because the desktop Docker, one of these little installation things that helps run it, kept getting updates, and you know, the updates are like 700 megs upwards to a gig. And I had one recently. I said, you know, I'm going to go play with this because I've got a data set from a class that I'm putting together for Udemy. So I figured, why not use that data set and just see what we can and can't do with it quite simply. So that data set has 85 images, so it's not this huge model. And I said, let's give it a whack. So let's give it a whirl. So WebODM is an open source drone mapping application. We're looking at their web page right now. So awesome drone software. Sustainable drone mapping software with a friendly community. That's awesome. I'm going to go down here and click on WebODM. So there's two ways to go at it. Number one, you can download basically the source and compile everything. You're gonna need to understand some command line stuff for Windows or Mac people, because this does run Windows and Mac and Linux. So we've got two options here. We got a manual install. So it's open source software. If you're a technical user, you don't mind getting your hands dirty, you're going to go to GitHub, you're going to get a copy of the source code, you're going to follow the README. I had a couple people comment on last year's video and said, hey, could you walk us through that? No, this gets a little more time consuming. So if you want it totally free, you're going to have to do some reading. And I can't do that reading for you because it's a little involved. And yes, I have read through it. The second option was a WebODM installer, which is what I went with last year because I said to myself, this is the cheapest modeling software I can get my hands on. So you're paying for the installation side of it. I'm just going to click on that. And WebODM installer, there's two different ways to go at it. You can do the standard and the business. They do give you an installation file for Windows or Mac, so that's great. I mean, look at the price, $57. I've got a lot of you on this channel getting in touch going, oh my God, Metashape's price, Pix4D's price. I totally get it. Drone deploy, maps made easy, all of these things are costing money. If you get a hold of this one, you're spending $57. If you want to put it on two platforms, if you want it Windows and Mac, $97. That's not bad for the modeling software. And I will say at the outset here, that I got some decent models this time. With that said, we're going to take a look at it. What I would suggest, maybe if you're getting your start in doing 2D and 3D modeling with drones, that this might be a path for you. And at that price, I don't work for these guys, so at that price, $57 for a single install or under $100 for two installs, that's cheaper than Metashape standard and most anything else out there. So if you just want to start getting a gauge of where you're at with your flights for modeling, this might be a great way to go. All right. So scrolling down once again, we've got the prices there. Business version has a couple of extra things going on, per user license, updates included. 1 year priority installation support. Note the word installation support. It's not the full software. It's that installer. So we got a couple ways to go. You can do the manual install. You're going to be doing a lot of reading. You're going to be downloading things from GitHub. So there's that way if you just want to go the total freebie route. But since I did the installer, hey, some money's going back to this open source development community, so that's great. Before I go any further, let's do something exciting. We always lead off with boring. We need some exciting. I just pulled up Photoshop and I'm looking at my Orthomosaic that is part of the course that I'm developing on drone construction progression reporting and sites. And so this is one of the orthos used for the clients to show them the area, show them the major changes in the area. This was created with Metashape. And what I want to do now is click over. We're looking at a completely different image. So up here on the left-hand side, we have WebODM.tiff, and then we've got 42620 Orthomosaic. This is the ortho generated by WebODM. Looks pretty close to what I got out of Metashape. So not bad. As I zoom into it, I do see some issues, some artifacts, some melting edges. And I did run this on a very low quality setting with WebODM. They actually have a fast ortho mode, which we'll see in a few minutes. So it could be that if I didn't do it on the fast ortho mode, maybe it'd be a little cleaner. Who knows? But to get this output, to get this ortho two-dimensional model out, this was not bad, especially for the price. Okay, I'm going to minimize this here, and we're going to go back up to the top here. So we got the manual install, we've got the installer, and you can make your choices if you want to give them a little support and a couple dollars. The WebODM installer is not horrible. What I want to look at next is documentation, because this is where things run into some headaches in my mind, at least. So we have the official documentation page, README for WebODM, for ODM, README for WebODM. So we've got some documentation. The documentation isn't, super great. You're going to be doing a lot of reading. A lot of things that are built open source and shared through something like GitHub. There's a lot of programmers and engineers behind this, and they know a little more about the development of their software than you do. But sometimes these folks think we're all on the same page as they are, and that we can totally understand how these things come together. Why I wanted to scroll down on this, so this is all the GitHub information for WebODM. There's a lot to read and check out, but what I wanted to scroll down to, so it's a user-friendly commercial-grade software for drone image processing. Yeah, it does process the images. I also tried a 3D with it, and it worked okay, but we need some more testing with that. What I wanted to get down to is getting started. They start right away managing processing nodes, because you can use the network to process things. You can actually use other people's servers to give you a little more boost over the net. Sometimes you have to pay for it, sometimes you don't. One of the things, where are my files stored? So this is just to give you an idea. When using Docker, all the processes are stored in a Docker volume. There is a program that's running in the background on my computer called Desktop Docker. And this is what helps to launch WebODM. WebODM is actually you use a web browser. So I'm looking at WebODM now. This is my install on my computer. We're going to talk about it in a couple. Let's go back here. But just take a look at this. So I get it. You're learning drone work. You're learning drone modeling. You might be learning about GIS. Total information overload. And then we come in here and we say, where are my files stored? And hey, I'm feeling like the Unix days. I used to run Unix systems while doing network design and telecom. But we've got command line stuff going on. You remember DOS and our little command prompt in Windows? And I also have a terminal here on my Mac so that I can do some Unix command line stuff. But you're going to need to know a couple of things. I just want to know where the files went. Well, hey, the files are actually in this Docker application, and you can put them somewhere else. And that's a little complex, so I'm going to blow past it, because this is just to give you an idea. Going to have a little more learning curve. So when you're paying for these higher end applications, like let's say just Metashape standard, you're paying for a lot of development time. You're paying for documentation. You're paying for support. The prices go up for every part of that. Now, this is kind of, you're wading way into the deep end of the pool when it comes to setting up programs on your computers. And you're going to have to be a little more knowledgeable or take the time to do some learning. So, so there we go. Where are my files stored? Manage plugins, updates. This is what I wanted to come to. Recommended machine specs. So we are right now on screen here. We're using an iMac. It's got 8 gigs of RAM. I wish it was upgradable, but hey, Apple doesn't like doing that anymore for us. Let's look at the recommended machine specs because I've had some failures on this thing. And so this open source program might be a little more top heavy than some of the other programs out there. So they're saying 100 gigs of free disk space. That's cool and fine. Hey, we got external drives and everything. They're suggesting 16 gigs of RAM. So this machine right here is already psychotically underpowered for this. And reading through some issues that people have had, and I've had as well, it does come down to your processors and the amount of memory that you have. So if you've already built, let's say, a drone mapping computer, you might be good. Maybe you spec'd it out pretty high end. If you haven't, here's what I can say to you. With my 8 gigs of RAM on this and the processors that are on my iMac, I can do some lightweight work here. I cannot run high resolution stuff. It will crash. It does crash. And I'm going to show you that in a minute. I also have another Windows box that I've used for mapping. It's got 16 gigs of RAM. It's getting a little dated. And when I made the purchase from WebODM, I did in fact get the installer for Windows as well, but I had the same failures and crashes on Windows. So having that 16 gigs of RAM and the higher end processor still didn't help get me past that. All right, I'm going to arrow back. So there's some rating to do. I already see that it's 12 minutes in. I do apologize, but for those of you who are used to this channel, when I do tutorials, I try to tell you about everything that I can. I think it's really important. Skipping steps in a process is not going to help you. A longer video where we talk about these things usually is more meaningful. So my videos go long. I'm not going to apologize for that. All right, I'm closing this. So I just want to look at this before we go down any other road. So this is a common error that people get when they're running these things, and this is what discouraged me last year and why I set WebODM to the side. So this person was trying to run a model, so they're on Linux, and in the end, they got this process exited with code 1. This is a generic code, which usually means you don't have enough memory. All right. So going back to the specs for the computers, good processors, plenty of memory. So this person, reading through, there's this whole giant thread. There's a couple of things you can do and a couple of things you can change. That's great. In the meantime, though, your model failed and it's frustrating. You are going to be investing more of your personal time to learn this in depth in comparison to one of the more expensive packages out there. There's the reality. That's the trade-off. So if you want something that's not as expensive, you're going to have to dedicate some of your time to learning more of the intricacies of the program. Now, let's look at the dashboard for WebODM. So from Desktop Docker, when I launch WebODM, it actually brings me into a web browser. So pulled up Chrome. And last night, I wanted to run a test for you. So I wanted to run a test on one of my models. And I wanted to do it high resolution. So this first thing, Clark Whalen, test number 3, testing for a live stream. I thought I was going to do this video as a live stream. I've decided it's easier to do it this way. That way I can edit it. And so we had a task. The task failed. Process exited with code 1, and it's got a sad face over here. That's cute. Thanks for the sad face, guys. It took 1 hour and 48 minutes of my computer's time to puke and say, I can't do this. Right below that one, I did Clark Whalen test number 2. There's one task, and this thing succeeded. All right. and it succeeded in 50 minutes and 44 seconds. I used the default settings on WebODM, and it actually worked for me. So it had some tasks: resize the images, load the data set, structure for motion, making meshes, making textures, georeferencing, digital elevation model, orthophoto, and post-processing. Anyone who's familiar with my Metashape class, the intro to Metashape, probably knows a lot of these terms. We do the image alignment. We're making our point clouds. We're doing meshes, textures, digital elevation models, and orthophotos. And what's really cool here, so this is something I like. I'm going to click View on Map. So it's actually showing off. There is my ortho model over my construction site. There's an opacity slider here, so we can slide this away to show you. Before this project began, and if you go look at Google Earth today, this is still the map you're going to see. This is the plot of land. Now I pull that opacity up, and hey, look, there's the construction site that I've been working on. So the data set that I had from the construction site that I've been using in Metashape worked out really well and worked with WebODM. Neat, really neat. This lined up pretty nice, but not perfect. If you look around this, if you hit the pause button, you'll notice over here, this driveway is not really lining up perfectly with the road. It's off by a couple feet. Same things on the other edges. What do you expect? We didn't do ground control points here. We're not using any kind of survey engineering GPS tools. So this was just from the flight. This is not bad for an ortho. I've had a lot of students on Udemy and people on this channel ask me, Rich, I just want to make an ortho on the cheap. WebODM. There you go. It can be on the extreme cheap. Let's go ahead, and down in the right hand corner I can hit the 3D button for our 3D model. Keep in mind, I flew this 90 degrees straight down. I was not trying to build a 3D model. I was building a 2D model. But this is kind of interesting because it definitely has, this is the point cloud, by the way, it definitely has really done a nice job with the structures. If you look at the sides, nothing. That's because I did not fly for getting the facades. But so we've got a decent 3D map or model here. This is something we could work with. So we can download the assets over here on the left. So we can do an ortho photo. We can actually export the point cloud for use in other programs. So we've got some tools. And if you're starting out, and to answer your questions about you need a cheaper way to do it, this might be a good practice point for you. So this might be the right program. Now I did a second one down here, Clark-Wayland testing. This one I ran just for the ortho photo, and they have a mode to run a fast one. And this one worked out as well. So I'm going to hit that view on map again. Same data set, different processing. But when we look at this once again, it's looking pretty good. Over in here, once again, we can see that things aren't lining up perfect. But we don't need them perfect unless we're dealing with measurement and dealing with survey grade accuracy. If we're just doing this to present a two-dimensional orthomosaic of before and afters, let's say for my construction progression reporting work, this could get you there. So, and this is decent enough. Now, when I zoom in, because like I said, I did it on a fast mode, we can really see some artifacting and some kind of ice cream melt. Look at the edge of this roof. Yeah, that's a mess. We've got some messy stuff down in here with these sunshade areas. So as I zoom in, it's not great, but I ran it on the fast processing. All right, let's go back to the dashboard. And what I'm going to show you one more thing. I know we're at 20 minutes, but this is necessary. I'm going to add a new project for you. So YouTube demo. There we go. So demo of a WebODM setup. We just created the project. Here's where the project is in my web browser. It's YouTube demo and it's got my information. Let's go select some images. I'm trying to be as quick as I can. So I'm grabbing the images from a flight I recently executed for a client. If you want to see more of this, I do have an upcoming course on Udemy for drone construction progression reporting, and I'll be announcing it here on channel when the class is out. It's almost ready. I thought it'd be ready for May 1st, but today is May 1st, so it'll probably launch next week. So I'm picking 84 images out of this flight set, and I'm hitting the open button. And now this is where WebODM brings us to. So this is how we make things get processed. Not too much information in this screen. We can switch to another processing node. So if we had a network set up, or if we utilize somebody else's network in the cloud, we can process this faster. And we could do some higher resolution stuff because we're using their computing power. So we've got a bunch of options down here. So this is the big thing. Right now you saw that it was checked off at high resolution. That's because of the test that I ran for you last night, the test that failed. If I select default for this image set, it works. If I select fast ortho photo for this particular image set, it works. Where I get caught is doing the high resolution, and it's most likely because I've got 8 gigs of RAM and I could use a faster processor and some more RAM. I'm not spending that right now. So default and fast ortho have worked well for me. They didn't work great for me last year, so hey, we've got some improvements. We've got some other things. We could do points of interest, buildings, 3D models, volume analysis, and we can also select custom. I'm going to go to default here. If we go for a custom setup, there are a lot of settings in here that you can affect that can change the quality of your model. Maybe it'll even let you run larger models on a smaller system. But, all right, let's see here. PC-classify, classify point cloud outputs. So using simple morphological filter, you can control the behavior of this option by tweaking the DEM parameters. Default is false. There are a lot of buttons in here. So SMRF, scalar, position float. You know what it is? I mean, I can go research and find out what this is probably. Simple morphological filter, elevation scalar parameter, default 1.25. Okay, I'm going to scroll down in here now because you need to see all of these settings. Whoa, there's a lot of settings. There's a lot of settings with things that we might not know about quite yet. So if you want to get into higher end modeling and mapping with WebODM, there is going to be a bigger learning curve. It doesn't have the nice clean interface that we've come to be used to with Pix4D, with Metashape, dealing with drone deploy, dealing with map pilot. Lots of decisions are made for us. Here, we can make a ton of decisions about how we want to fine-tune our model. So this is where the bigger learning curve comes in. And I was looking at WebODM, and they do have a 200-something page ebook from someone on this. So some of the answers to what all these buttons mean and what are these things, because I'm sure, SMRF window, positive float. Is that a Smurf window? I don't know. We can find out. Simple morphological filter, Windows radius parameter. Why would I want to change this? What is this going to do? How is this going to affect me? We need to do some more reading. I'm going to hit the cancel button. In the meantime, if you are just testing out some simple modeling, not doing giant massive models, not trying to do super high quality, high resolution, this might help you in your first steps into making 2-dimensional and 3-dimensional models. So as I said, fast ortho worked really well and pretty darn quickly. And default worked pretty well and pretty darn quickly. I had a data set with under 100 images going into both of these. How big can I go? I might test that later on another project that I'm working on. And if something interesting comes out of it, I'll follow up on this video. So what I know for today, under 100 images, default and fast ortho get me there. And they work okay. I'm going to go ahead and hit cancel on this. If I were to go ahead, if I hit review, so there we go, review, and then I hit start processing, it's going to start pulling all of my images in, aligning my images, and then running through a checklist. I'm going to hit this cancel. I'm going to hit cancel again, and we can go down and look at that bottom one. So the checklist that it goes through, it resizes the images and uploads them to WebODM, loads the data set, It's going to make our cloud. It's going to do our meshes. It's going to do the textures, georeferencing, digital elevation model, the ortho photo, and post-processing. Running the super fast ortho model one that I showed you took 22 minutes and 40 seconds. That's something I really dig. WebODM's got it right there because it told me exactly how much time went into this. I'm a fan of that. All right, let's close that task. Let's look at number 2 real quick. And so task number 2, I did that with the default settings. So didn't go changing any of those crazy buttons there. And with the default settings, same exact data set, same exact image set that was run for the fast ortho, now took 50 minutes and 44 seconds of processor time. So that first super fast one was a little under 25 minutes. The second one is now at 50 minutes. And it was a default one. There are options for the high resolution ones and things. And you saw my high resolution one, that was an epic fail processed. That took 1 hour and 48 minutes of my computer's time to make the decision that, whoa, I can't do this. I'm keeling over here. I'm not that old of a computer, but it's too much. So there is a quick overview, 26 minutes, sorry. There's a quicker overview of WebODM. Do I recommend it? Do I not recommend it? Here's the thing. I just showed you the 2 ortho models. It did a really nice job for me with that ortho model. How big of an ortho model can I do before it crashes and gives me a code 1? I don't know. But I think I'm going to go experiment on one other data set that I have and then do a follow-up next week. Now, I'm interested in getting the book for WebODM, that 200-something page book, and that's available under their documentation, and that might really help us fill things in. But as a drone pilot and someone who's looking to build their own drone business, like you're most probably considering because you're watching this channel, reading is involved in all of the stuff we're doing. You had to learn some new information getting your Part 107. You've had to learn about mapping and modeling. You've had to learn about drone flight. We've got another step in the learning process. Doesn't mean it's a bad thing. And maybe in the end, we can get a lot more out of WebODM than I've seen so far. So maybe you could do some reading too, and we could collaborate together here on channel to see how far WebODM could take us and our businesses. All right, everybody, I'm wrapping this one up. I hope this was a useful video for you. I'd really like some feedback on this, and I'd really like to know, do you think it's worth going down this path, digging into this and seeing if we can make something with it, finding out if maybe, in the case of Metashape, let's say, it processes my models as well. It takes a long time. Sometimes it takes several hours. Maybe there's a way to tweak things here so that it doesn't have this, out of RAM kind of code. And maybe we can tell it, go ahead and take your time. We're not in a hurry. I don't know. That's something I haven't found out in here yet. All right. If you're interested in this and you don't mind doing things from the command line, you can get a hold of this program for free today and start experimenting. If you want the installer and the fancier interface and not worrying about command line, it's $57. If you're a coffee drinker, what can I tell you? A couple of skips Starbucks will do it for you. All right. I'll see you guys on the next video. Sorry this one overran, but I hope it was informative. And I really look forward to hearing back from you to see what you're doing with this, because I'm starting to think there's more possibilities here than I thought there were last year. All right, we'll see you.